Good morning, good afternoon, good evening. Thanks for joining this instance of the Antrea community meeting. Today is Tuesday, November the 21st. For today, we have a very packed meeting agenda. We will start with discussion of some GitHub issues pertaining dropping Docker on Windows, and this will be led by Antonin. Then we have a presentation from Wenning regarding implementing egress support on Windows. And finally, if we will have time to discuss all of them, we have a series of GitHub issues concerning the usage of Antrea as a secondary CNI. So basically not the primary plugin in a Multus environment. There are three issues that have been highlighted on our Slack channel, plus a fourth one that was added by Jun yesterday. So I don't know, honestly, if we'll have time to go over all these issues. We'll treat them in a best effort way, and the ones that we cannot discuss in this meeting, we'll discuss in the next meeting. Say that, considering that we have a very busy agenda, let's start with today's topic, and let's start with dropping Docker on Windows. So Antonin, please go ahead.
Yeah, thanks, Salvatore. Let me share my screen. All right, is it working?
Slowly? No, it's not. It's strange. I can only, at least for myself, I can only see the window title. Window.
Okay, that's funny. Let me try again.
Yeah,
Um, what about now?
it's good now.
All right. Hi everyone. So I wanted to discuss one of the installation methods that we have for Windows, and that's actually the first installation method that we've ever supported for Windows, and it's based on a third-party project called Wins from Rancher. And I linked a GitHub issue here, and as Salvatore mentioned, the GitHub issue is a bit like more aggressive in that it suggests like dropping support for desktop on Windows Node altogether. And I'll discuss why those two things are actually well, not exactly the same, but very similar. So first, a brief overview of what it means to run Windows containers on Windows today. There is like a good blog article from Mirantis, which is actually pretty objective on the topic, in my opinion, and basically describes the four options you have to run Windows containers today. The first one is Mirantis Container Runtime, which was formerly known as Docker Enterprise Edition before it was acquired by Mirantis. Basically, it's a container runtime with enterprise level support, and you need a relationship with Mirantis to be able to use that. You need to purchase a license from them, and it has pretty good support for Windows containers, allegedly. The second option would be Docker Desktop, which is like, well, probably most developers are familiar with Docker Desktop. It lets you run both Linux containers on Windows using a virtual machine, and also lets you run Windows containers on Windows. One important thing about Docker Desktop is it is not available on Windows Server. It's only available on essentially Windows personal editions, Windows desktop editions. And it also may require licensing because of licensing changes to Docker Desktop 2 years ago. So when you're using it as part of a company, for example, it requires licensing if the company has a certain size. The third option is Docker Community Edition, which I'm also going to refer to as Moby. And that's what like a lot of people are using when they're using Docker on Linux typically. And it can also let you run Windows containers on Windows. It's a bit like challenging to use. I think it may not be the most active community project these days, but it's still here. And the last option is Containerd, which has become like a first-class citizen in Kubernetes and is getting a lot of like active contributions from Microsoft directly. One thing to note about Containerd is that it's kind of like strictly a container runtime, and it doesn't let you build containers. So you would still, for example, use Docker Desktop or Moby to build a container. But then you can run it on Windows Server using Containerd directly. And finally, I want to mention, and we'll cover that later, that supporting running Windows containers on Windows doesn't exactly mean Windows Kubernetes node support, because not all of those options are appropriate for Kubernetes, for example, Docker Desktop. And those are the installation methods that we currently support on Windows. So we have three different methods, or four, depending on how you look at it. The first one is the one we're going to discuss in this presentation, and it's Rancher Wins. It supports, according to our documentation, should be used for Docker only, but I think there is no reason why, in theory, nowadays it would not work on Containerd. We just don't advertise it for Containerd because there are better options for Containerd. And we have a YAML manifest for that. That's kind of like our default YAML manifest, once again, because this is historically the first installation method that we've added for Windows. The second one relies on Windows services. So you run Antrea node components as Windows services. And we recommend this installation for Containerd. But once again, I think that besides historic reasons, there is no reason why you would not be able to use that with Docker. I think you should be able to use that with Docker container runtime if you wanted to as well. And because this is using Windows services and not Kubernetes resources, we don't have a YAML manifest for it. We just have like scripts to let you install and register those Windows services. And the last installation method, which is the most recent one, and I would say overwhelmingly the most recommended one for new users, would be using the host process container support from Kubernetes. And I guess I didn't include like detailed information about that, what that is, but that lets you run essentially privileged containers in the host network on Windows nodes. And in order to use those process containers, you cannot use Docker. Docker doesn't support it, but you can use Containerd. It requires Containerd 1.6 or greater, and I think according to the Kubernetes documentation, Containerd 1.7 is recommended. And for this method, we provide two different YAML manifests based on whether you want to run the Open vSwitch daemons as containers or as services. So we have one YAML manifest which assumes that you're running the OVS daemons on the host by yourself. And we have one YAML manifest that takes care of running everything, and it was added recently. And a quick recap on the Wins installation method and how it works and why we started using it. So the key part about Wins is that it supports managing Windows host processes from Docker container. So you have a Wins server, which is running as a process on the Windows host, and then you can run a Wins client inside the Windows container and kind of like tell the server what to do on that Windows host. And that gives you the ability to manage the host network, which obviously is a requirement for Antrea, because we have to configure the host network, called the HNS APIs and so on. And what was appealing about this method is that it lets us manage the lifecycle of an Antrea agent using a daemon set. So it makes the installation method on Windows similar to what we're doing on Linux, where the agent's lifecycle is managed from pods. And of course, it predates host process container support in Kubernetes, which is basically, it feels like a similar purpose, but using a third-party project. And so I think an interesting question, and the reason why I'm doing this presentation today is there a legitimate use of this installation method today? And I think a key point to understand is that today it is only useful when you really want to use Docker Community Edition or Moby as your container runtime. Because if you're using Containerd, you have essentially better options, especially if you use a recent version of a recent enough version of Kubernetes with a recent enough version of Containerd, in which case you can use host processes. And so the point I'm trying to make here is that, of course, you would only use this method with Docker, and there is no legitimate use case really for using it with Containerd. And here I have a list of reasons why I think we should drop support for this method. And you'll see that essentially a lot of those reasons boil down to why we should drop Docker support altogether as a container runtime. So the first one would be that there is no strong reason to use Docker instead of Containerd, except for building containers, of course, which is irrelevant in this case because we're looking at running containers on Windows Kubernetes nodes. Ever since Docker shim was removed from Kubernetes, I believe that using Docker actually requires installing CRI Docker D, which is a CRI implementation for Docker on your Windows nodes. So it makes like deployment and provisioning more complicated. One other thing is that it's actually no longer listed as a supported container runtime for Windows. If you look at the Kubernetes documentation, and I put a link here, the only supported options according to the documentation are Mirantis container runtime, the commercial version of Docker Enterprise, and Containerd, kind of like the widespread community option for this. And I believe these are the only two listed because those are the only two that support host process containers, which is basically an assumption that Kubernetes is making now. Docker has been replaced by Containerd by all the Kubernetes as a service providers. Here you have like the different versions where they switched over from Docker to Containerd on Windows specifically. Obviously, they also switch over to Containerd for Linux, typically before that. One question that came up when we discussed this was like, did Google Anthos, which uses Antrea for Windows nodes, ever use this installation method? And I wasn't able to confirm it, but I believe that they did not. In version 1.11 of Anthos, it just switched from Docker plus Flannel for Windows nodes to Containerd plus Antrea. And so there was never any Docker plus Antrea usage in Anthos. This one I didn't confirm yet as well, but I believe that even if we wanted to support Docker, which I definitely do not advocate for, I feel like the Windows service installation should also work. There is no reason, I think, why this would be specific to Containerd. Please correct me if you're familiar with this and I'm mistaken.
Sorry for interrupt you. Anthony, just I want to add one comment is because Tanzu is still using the Windows service,
Tanzu is still using the?
using the Windows native service to run Antrea agent, not using pod to run Antrea agent on the Windows node. Even they use Containerd for
Oh,
the
sure,
container
sure,
runtime.
but I'm only talking about Docker and Wins here. I'm not
Okay.
advocating for Windows service removal at all. Yeah.
Oh, sure.
Yeah. And so Wins is also the Wins project is actually not actively maintained. I don't think it's used very much right now. It has very few GitHub stars, I think, if that means anything. And I think one of the most important point here is that we do not test this method in CI anymore. We test the Windows service installation. I believe we test the host process installation for Containerd, but we no longer test Docker support at all. And so we no longer test this method in particular. And of course, this would simplify our documentation, which is a bit complicated for Windows installation, just because we have all those different cases. And yeah, here's what I'm proposing concretely. I think that in the upcoming 1.15 release, we should deprecate that installation method completely, just mention in the documentation that we no longer support it. And I think in Antrea 2.0, we should remove it from the documentation. And honestly, a small step from removing this method in my mind is to announce that there is no more support for the Docker container runtime on Windows. We have a little bit of Docker specific code in the CNI server on the agent, which we could probably remove if we decide to drop support for Docker. And here I'm kind of like emphasizing again that we cannot really claim support for Docker container runtime on Windows anymore because we do not test it in CI anymore. So it's probably a good idea to drop it altogether if it's no longer used in the wider community. All right, that's it for me. I'm happy to take questions about it. Or get
Hi,
comments.
Tony. I have a question about the first one. You mean to deprecate the installation method? What kind of change we should do? The document one or the code level?
Oh, I think just the documentation on you. Yeah.
Okay. Okay. Thanks.
Yeah, even for the second bullet point here, there isn't a lot of code changes required. It's just that we do have like a special case, I think, for the Docker runtime in server windows.go because something to do with the infra container and how like the sandbox is created. So if we only support containerd on Windows, we could probably remove that code.
Hi, Anthony. I have a question about the CI script. So, since you mentioned that we have removed it in the online CI pipeline, so I think maybe in 1.15 we can also remove all related CI script and job YAML for the Docker, right?
Yeah. So we still have those scripts, but we don't run the test anymore, right? For pull request today.
Yes. In
Okay.
recent releases, we didn't trigger the Docker jobs.
Okay. Yeah. Yeah. I'll add this to the issue. Thank you.
Sure.
Hey Anthony, there's one area which Vening touched on just now, like whether in future we'll be supporting running OVS user processes as a service, because anyway we are supporting now container-based running container-based OVS processes. So I think running OVS user processes as a service, are we planning to deprecate it, or are we planning to support it?
Well, I haven't thought about this too much. So you're talking about the second installation method here, or?
Yeah, correct. Yeah, second installation. So both are doing same thing. So probably we want to deprecate the service-based support for the OVS user processes going further, or we want to support both?
Well, I would say that's a separate issue. I mean, as Wanning pointed out, this is still the installation method used by the Tanzu Kubernetes distribution, apparently. And so we may want to keep it for a little while. I think, sure, maybe in the future, we could try to see if we can have a single installation method.
Yeah, I think, yeah. Go ahead, Wendy.
Sorry. Yeah, I just want to say that I think recognition is asking about third, uh, the third line about if we expect to run OVS user space on the node as a Windows service, or we expect to run OVS inside the containers along with Antrea agent container.
Oh, you mean the Okay, you mean the first
Yeah,
the
two
first
YAML.
manifest
Yeah.
for the okay, yeah.
Yeah, more specific on that.
Yeah. Oh, well, the answer is kind of like the same for me. I don't have like a strong preference. If we think like it's not needed anymore, then yeah, we should consider removing it.
Yeah, I think in that sense, it will be very clean because the OVS user process will run in container, and we don't have to kind of do a lot of installations, which we are doing for service currently on the host. So that would kind of be a better option, I think. So maybe we can take
Yeah, I
that.
agree. It's a much simpler option, and if there is no trade-off, then yeah, I don't see why we would need to keep supporting both options. Yeah.
Yeah.
Actually, personally, I still think we may need to maintain the two because you may know that for Antrea open source, we are using the open source OS, and also in the Antrea Windows image, we are still using the open source OS, which was not signed on the OS driver. But I'm not sure if we have some customers which has the signed OS drivers. If they have, I don't think they can. They expect to use our provided open source OS in the on the Windows Note. So if we only have a single manifest which involves OS, and we expect OS must be run inside the container, then that means that we cannot support the case for example, for the commercial Antrea, which expects the user to use a commercial OS signed drivers. Then I don't know if we could trade off our support in that case if we only maintain one YAML. Then,
Okay, let's take this discussion offline because it's it's a bit orthogonal to this discussion. We can revisit the other installation methods offline. All right, if we don't have any other comments, I think back at you, Salvatore.
Yes, thanks, Antonin, and thanks for this presentation. And now we move to let's say, the feature presentation that we are planning for today, which is still on Windows, and it's about egress support. So, Wenning, please go ahead.
sure. Thanks, Salvatore. Let me share my screen. Um, can you see my screen?
Yes.
Okay. Thanks everybody. Then I will present a proposal for implementing egress on Windows Node. First I will talk about the motivation. As we all know that egress feature is now in the beta stage, but for Antrea, we only support running egress features on Windows Node at the current moment. That means that we can only use an egress IP address on a Linux node, and we can only support Linux ports to consume the egress IP address as a source to access the external servers. So the motivation is that I would like to introduce the feature on Windows so that we can get this target. Firstly, we can provide egress IP address on a Windows node, and we can support Windows ports uses an egress IP address which is configured either on a Windows or a Linux host to access external addresses. And also we can support that even if we configure the egress IP address on Windows node, a Linux port can use the egress IP address to access the external addresses. That is the target for this proposal. And to be consistent with our existing implementation on the egress feature, I provide this diagram to show the traffic path. For example, we have two nodes in the cluster, and we have configured some egress IP address on the node 0. Then our egress feature is like this: that if a port which was tagged with the expectation to be selected by the egress scenario, then the pod 0 can access the external servers using the source IP address of the egress. And also some pods, even they are locating different nodes, they can use a tunnel that's with the egress IP to forward packet to the node where egress IP is located first, and then use the egress IP address as a source to access the external server. So this scenario is supposed to be suitable on Windows node or Windows pods after this proposal. Then to achieve the general requirements, what we need to perform. Then firstly is we need to enable egress feature gate on Windows Node. So that means that we need to remove the egress feature gate from the unsupported feature gates on the Windows list. And secondly, we need to support configure egress IP address on Windows nodes. Then it means a Windows node can join into the cluster, and the Windows can join the election in the cluster to get the egress IP address on itself. And from the data path support, we need to support responding ARP queries on the egress IPs on Windows Node if it is assigned on it. And there is some note I want to highlight here is by now we still do not support IPv6 on Windows. So the IPv6 NDP protocol or NDP advertisement message is not required on Windows now. And secondly is that we need to support using tunnel to send pod traffic to a node where egress IP is configured. Here the node can be a Windows node. And the third requirement is that on the data path, we need to perform SNIT on the pod traffic, which egress is applied to. Then what we should perform on actions. First is that we need to remove from the unsupported features on Windows, and we also need to add the feature gates on egress related configurations on the Windows configuration. You may here, maybe you know that so Windows has a separate configuration which is independent from our general Antrea YAML manifest. So we need to add the related configurations in this file so that if the user want to disable egress in some scenario on Windows Node, he can operate it on this. And then about how to configure egress IP address on Windows Node. Firstly, we need to remove the node label filters on Linux. This is something existing in the code when processing the node join or rejoin events. So it means that without this filter, label filters, the Windows node can join the election. And then we need to implement interfaces of IP assigner on Windows nodes. Here I want to highlight something. One is that there is no dummy interface created on the Windows node. This is something different from the Linux. And the second is that the local IP configured on the OS interfaces are automatically detected. For example, we know on Linux if user statically specify some egress IP address already configured on the dummy interface, then the Antrea agent on Linux will automatically detect the local IP address. And on Windows, as we do not have the dummy device, we can support the auto detection only on the IP address configured on the OS local interface, on which the Windows node IP address is configured. And the third thing is that about ARP responder. For ARP responder, the usage on the Linux is for two scenarios. One is that if the ARP autoresponder configuration, this type of configuration is not enabled on the Linux node, we will use some user space user space processes to respond to the ARP query, so that some other node, some other servers can identify that this egress IP address is configured on which node. So on Windows, we also have similar solutions to in this requirement. But on Windows, we can just use static openflow responder flow trace on the OS to respond to the packets. As we assume that the IP query for egress IP address is always coming into OS interface from uplink, then it firstly can be processed by the OS. Then if we have some openflow entries here, then it can automatically respond the query with the response packet. And the second requirement for ARP responder is to send gap packets when new egress IP is assigned on the current node. This may be suitable for some cases. For example, egress IP is firstly assigned on a new node, or some egress IP is migrated from the previous node to the current node. So on Windows, we may also need to think about this case. So in my proposal, I have two options to support how to send in the gap packets. One of option one is that is similar to the Linux. We can use some Windows native raw socket to send the gap packets, and the socket can be listening on the OS local interfaces, which the IP address is which the node IP address is configured. And the second option is that we can just use the OS packet out message to output the gap packet to the uplink interface. The second option is just because the special topology for Windows, as we may know that on Windows we already configure the uplink to OS, so we can simply operate the packets on the OS bridges easily. So here are two options. Maybe I need some input from everyone here to give the final decision on how to send gap packets later. And then about the bare path design. For bare path design, the first point I need to propose is about how to implement ARP responder on egress IP address. Where we can use openflow ARP responder to auto reply the query on egress IP address. So here I will introduce a new OS register mark from egress reg mark to mark the ARP query packet on the egress IP address in the ARP spoof table. Then we can use a static ARP responder flow in the ARP responder table to reply the packets. In the responder packets, the current Windows node mic is used as the source. So here I propose, I pasted two sample openflow entries here to show how to provide these functions. We have we've got table flow, and we will set the reg mark for the egress from egress reg mark here, and then we can consume the egress reg mark in the ARP responder flow to statically respond to the packet and send it out from the import port. And the second one is about how to perform SNIT on egress node. Here I draw the general diagram block here, and the right line is to present the path of request, and the green line is for the reply path. And one thing I want to highlight, something I want to highlight includes, firstly, we must perform SNIT on inside OS bridge. This is different from Linux, which was using the IP tables to perform the SNIT. And the second is that for the request packet, we firstly output packet from bare int or with a OS local interface to the Windows host. Then we can leverage the Windows IP stack to know that that's the MAC of the the destination IP address. Then the packet must be forwarded back to OS bridge from the same variant interface. Here, the path is different from with the general case for POD to external traffic, which is expected to output a POD packet to Windows host from the Antrea Gateway 0. This is because that on Windows we will perform Windows night to perform the S-night for general POD to external traffic, but on Windows night there is some limitation. It will perform the stateless S-night on the packet as long as the packet was entering Windows host from the Antrea Gateway 0. It means that if we follow the original path to output the egress S-night packet from Antrea Gateway 0, Windows host will still perform another S-night on the packet, even though we already perform it inside the OS bridge. This is what we not needed. So for egress case, we just change the path for egress packet, request packet to leave OS bridge first from the variant port and then back to OS bridge, then output to the external server. For the reply packet, the path is not so much with the request path. The packet firstly entering OS bridge from uplink, and after perform the NS-night, it is directly sent to the pod. Then we do not have additional walking path on the host on the reply packet. This is the thing, the major thing. So if we want to perform this path, forwarding path, on Windows host, we need to perform these changes. Firstly is how to perform S-night. We need to introduce a packet mark field to identify the specific pod traffic, which needs to be translated as the egress IP address. And here, I also want to highlight one thing that on Linux, we are using the packet mark field, which was provided by the OS, but on Windows, the Windows driver doesn't implement the related logic on packet mark, so we cannot use the existing field in the OS. We need to use a Windows register field bits to identify the packet mark. Then we can use this OS register to perform the mapping between egress IP address to the packet, just similar to the Linux. Then we need to perform the S-night on the request packet. We need to commit S-night operations in the S-night contract zone on the first packet, no matter it is sent from local port or remote port. And we need to perform S-night on the subsequent packets in the request direction. So to perform it, we need to commit egress S-night city mark in the contract zone. This is the D-night contract zone on the first packet to make it work. And then we need to enforce the subsequent request packets to tag with the egress S-night city mark to be processed with the S-night in the zone. Then after we perform the S-night on the request direction, we need to output the S-nighted packet to be int instead of Antrea Gateway 0. And here I just introduced another value in the two direction for the reg mark. Previously we only have two bridge, two gateway or two external, and then we need to have additional value of two bridge reg mark introduced. Then if we find for the OS data path, if it find a packet was marked with this, it will not output it to gateway 0. Instead, it will output it to the OS local interface. Then we can avoid additional to avoid unexpected S-night performed on Windows host. Then about how to process the reply packet on the egress traffic. Here we will use a learn flow to predict the expected reply packet source and that's the IP and perform an SNET on it. And I would like to introduce a new table, SNET predict table, to install the learn flow after the SNET is performed on the new connections. And the learn flow is installed in the SPOOFGuard table to enforce the reply packet targeting to a egress IP address from the external server can go into the pipeline. Here I just want to highlight something that why we must use the learn flow instead of a static flow using the destination IP address of the egress IP address is because that, as I mentioned, we need to use the tunnel dest IP address as the egress for the packets from a remote node to be correctly performed perform egress functions on the egress node. So on Windows, if we just simply using the dest IP address as the egress for the reply packet, it will also match the tunnel packet from a remote node. In this case, it will break the requirement that we expect a pod from a different node can perform SNET on Windows node. So that is the.
I have a question here.
Yeah.
If it's internode tunnel traffic, it must be UDP and use the specific port, right? Can we use the protocol and the destination port to differentiate the two traffic?
But from configuration, do you mean some enhancement on the learn flow or?
No, I mean because you mentioned why we need to use learn flow is but instead of static flow matching the egress IP is because you want to differentiate the two traffic. I mean the reply egress traffic and the internode egress traffic should have different attributes. The internode port traffic should be encapsulated and should use UDP and use the specific port, but the return traffic of egress traffic, the return egress traffic should be different. I mean,
I know your question. You mean that we can use a high priority flow to specify the tunnel packets from a remote node using the UDP protocol and that support with, for example, GNU ports. But the thing is that in OS, at least on Windows OS, I didn't find a valid action to decap the tunnel traffic explicitly. So even if we specify this traffic, I don't know how to set action to perform the decapsulation. I don't know how to program the high priority flow.
You mean perform decapsulation?
Yep. I think your expectation is that we have two open flow entries. One is with a high priority, for example, 500, and we expect to matching the UDP protocol with GNU ports, and the destination IP address is the egress IP, which is expected to match the packet which was tunneled from a remote node. Then the action we expected action in this matching flow is to decapsulation the packet so that we can use the tunnel properties in the later flows. Is that correct?
Yeah. So the problem is actually you can do nothing to ask for a decapsulation, but how to make OS implicitly do it. without
So
any flow processing the packet first. Right.
So you mean that your expected flow is with the matching and the action just resubmit to the next table or something like this?
I felt there should be some ways to do it, because if I get it correctly, the flow should leave the UDP internal UDP traffic as is, and do not touch them, and only process the other traffic with this egress IP as destination IP, right?
Yes, but the thing is that when we install OpenFlow entries, we cannot specify no actions in OpenFlow entries. We cannot have an OpenFlow entry, only have the matching conditions, but no actions. This is not allowed in OS. So if we want to install such a flow, we must provide expected action. But so we do not have such action supported in OS. That is the question.
I'm thinking only resubmit the traffic we are interested in. Sorry, we submit the internal UDP traffic to the next table, and that it goes through the rest of the pipeline, and we perform on DNet in this table for return traffic or for the egress traffic.
The experimentation is that the test shows that this is not correct, because if we just resubmit the packet to the next table, the OS will think it is just a general UDP packet, not a tunnel packet. It will not perform tunnel encapsulation and anymore. So we cannot we will not have we will not see the inner source and destination IP addresses in the packet. We just see the outer.
But at which point OS thinks this is a tunnel packet? After pipeline, or amid the pipeline, or before going into the pipeline?
In fact, there is no explicit configurations or actions in OS pipeline to require OS to decap tunnel or something like that. Just some operations in the OS data OS driver or OS kernel modules. So if a packet comes here and it is not matching any explicitly added OpenFlow entries, it will try to see if it is a tunnel packet. But as long as not OpenFlow method.
Anyway, it will match one flow, right? For example, even you don't match the destination IP explicitly, you still have some classifier which could match that packet, right? I don't get why if we make a flow matching the destination IP explicitly, it will have different action. But the packet anyway will match at least one flow, right?
No, for my proposal, I just list the untunnel packets using the learn flow. So for a tunnel packet here, it will not match any packet matching the tunnel dash port or on UDP protocol. Then it will try to see if it is a tunnel packet. But as long as we have another OpenFlow entries to tell OS if a packet is matching the GNU port with UDP protocol, it cannot perform the tunnel packet anymore.
Perhaps we could discuss this offline.
Sure.
I think we need more discussion about the details. Thanks.
Then I can continue this. Then after we use the learn flow to explicitly matching the reply packets. Oh, sorry. Right. Here. We need to modify the selections with submit to ensure the reply packet to process in the pipeline. And we also need to highlight, we must cite the right mark on the reply packet to ensure that the unisolated packet can be forwarded correctly. Then about the tunnel packet here, it is similar to the power traffic from the local node with the egress. The only difference is that from a remote node, it will use the tunnel dest with the egress IP address as a destination. And the reply packet will firstly come back to the egress node and perform unisnet. Then it will be forwarded back via the tunnel to the client node. So to support the tunnel egress scenario, we need to use the flow-based settings on Antrea tunnel 0. Here is something I want to highlight. Another thing I want to highlight in this meeting is that we must use explicitly set the local IP equals to flow on the Windows OS bridge on the Antrea tunnel interface. This is something different from the Linux OS association say that this is not required on Linux, but only required on Windows. And also, this is some changes from the previous implementation on Windows, where we may use the Windows node IP here to set the local IP property in the options. So this change is because that if we do not use a flow based on the local IP, the OS on Windows node will not receive the packet coming from the tunnel using a different destination IP from its node IP address. That is what I have tried in my test. So this change will be needed here. And we also need to use the match condition for tunnel dest IP to identify the packets sent from a remote node. And we also need to cite the tunnel source IP with the tunnel dest IP with the egress on the remote node. That is the something for the tunnel scenario. And for development plan, I just expect to have the code ready in Antrea 1.16 because of some bandwidth limitation. So Savato, do I have some minutes to
we have
make
5
demo?
minutes. Yes, please go ahead. We will discuss the issues pertaining use of Antrea as a secondary interface to the next community meeting, because otherwise it will take too much time. But we have 5 minutes for your demo. Please go ahead.
Thank you. This is my sample, and I have egress configurations here, and I expect to match the allocated the IP ranges for the egress, and I need to match a node with this label, which already tagged on the Windows node here. So I will try to apply egress here, and then we can have the EIP, and we have the egress configured here. The status shows that the Windows node will be selected, and the IP address is assigned from the range. And then I will start a server to simulate the external IP address here. Then I will try to sorry, we still have some ports to be selected. Get ports. Right here, and we will have 2 ports. One is relocating on the Windows node where the egress IP address is configured, and I'm not sure. And another port is locating on Linux node, which will be using the tunnel to access the external server. Then we can try to see the IP here. So we are using the egress IP address to get the traffic. And now we are using the Linux pod, and we also have a test to work on the Windows pod. And we also have another traffic case using the egress IP as the source. This is my demo. Thanks.
Thanks.
I
Yeah, go ahead.
to
Right,
Do we
thanks.
have any user requirement for this feature?
By now I didn't have the requirements from users just because of some comparison on the feature gate status.
Okay.
And I guess a follow-up on that, could we make the feature implementation much more simple by saying that egress nodes are always going to be Linux nodes, but we can still enable the egress feature for Windows pods. It's just that egress IPs can only be allocated to Linux nodes because clusters are always going to have Linux nodes, right? Typically, you're going to have a lot of Linux nodes and potentially a few Windows nodes.
So you mean we need to modify the requirements so we only support the Linux node as the egress. So but we need to support the tunneling to the handle the Windows pod traffic to the Linux egress node. Is that correct?
Would that make the feature implementation simpler or that's because I think that would be a reasonable assumption. I mean, other people may disagree, but I think that's a reasonable assumption. And then if it makes the feature implementation simpler, then maybe it's a good place to start.
From the code perspective, I think it can be supported, but just for the feature requirements level, I think Jianjun and Quan maybe give some comments here.
I think Antonio's suggestion is a good compromise because with egress feature, anyway, you just expect the traffic use specific IP. You don't actually care about the actual node, and even you can use Windows node as the egress node. It doesn't have to be, and in most cases, it won't be the node the port itself is on. So perhaps from users' perspective, it makes no difference for them to use Windows or Linux node as the egress node. However, since the cluster already has Linux node, perhaps it's simpler to just use Linux node as the candidate nodes, unless there is a available zone limitation in Linux nodes that all of the nodes could potentially be down, but and it's not the case of Windows nodes. But I don't think it's likely the case in reality.
I have one comment on this. So in a cluster, let's say we configure, we have Linux node as well as Windows nodes as worker nodes, and we might want to configure egress IP on the Windows node. So what will happen to the Linux node? Like how the Linux worker node traffic will be going out? Like it will be going via Windows node only because egress IP has to be cluster wide, right? So in that scenario, it will be like what Antonin said is like mostly towards configuring egress IP only on the Linux node, and then all the egress traffic going via Linux worker node. But if we support on the Windows node configuring egress IP as well, so then we have to take care of if the egress can be done for the Linux worker nodes via Windows worker node. Is the right use case? Like if you can only configure one egress node on the Windows node, in a cluster, having multiple Linux and Windows node.
So, Chen and Antonio, do you think Rashni's scenario is valid or invalid according to your experience-based customer troubleshooting or something like that?
Can you repeat the question? You mean user assigning egress IP to Windows Node manually, or you let the Antrea agents to negotiate the egress node, and finally the Windows node is selected?
Yeah,
Which
that's
case?
Yeah, finally
you
Windows
mean,
node is selected. Yeah.
Oh, I think Antonio's proposal is to exclude Windows nodes from the candidates, so it will never be selected. Right.
Yeah, I have to say it would be a bit weird to end up with Linux pod traffic egressing through a Windows node, you know, if a Windows node is selected for the egress IP. Typically, I think it's fair to say that Windows nodes and Windows networking may not always be as stable as Linux networking, right? So if like if a user of Antrea has one egress node in his cluster for experimenting purposes, and we end up choosing it for the egress IP, I think that's a situation we may want to avoid. I think that's like a benefit of always excluding Windows nodes as egress nodes.
So basically, we'll have to exclude Windows node as egress node.
Yeah. But my main point was that it simplifies like the implementation, ARP response, all that stuff. If we can assume that Windows nodes are not going to be egress nodes, because we already have that functionality on Linux, and now we just need to make sure that we support tunneling traffic from the source Windows node to the Linux egress node.
Maybe I can add this Antonio's comments in the future issue, so that if we have additional suggestions or comments, we can add it on the issue page. If we do not have other questions, I think I will handle back to Salvatore.
Thanks. And we are unfortunately already 5 minutes over time. So the only thing that I can do now for the meeting is to thank Antonin and Wenning for their presentations. And as discussed with Chan, there will be follow-ups regarding implementation of flows for the Windows egress feature. And for the other topic in the agenda, which was pertaining usage of Antrea as a secondary CNI, in general for secondary network interfaces, we will repropose this topic for the next community meeting on Tuesday, December the 5th. So thanks everyone for attending. I wish everyone a great day, great afternoon, or a good night, and talk to you in 2 weeks' time.
Thanks.
Thanks.
Thank you.
Thank
Bye.
you. Bye-bye.
Thank you, bye.
Bye.